Okay, for today's class, we're actually going to do three short lessons, and I've broken them up into three separate videos so that I don't rush it and it's a little bit easier to consume. So the first one we're going to look at here today, the first topic is called mixed derivatives. And what this means is that sometimes if you're looking at a more complex function, it may require more than one of the derivative rules to actually find the derivative. This begins on page 42 in your textbook, and I'll just dive right in and look at the first one right here. We have f of x equals, and you can see a fairly complicated function there. We have x to the power of 3 plus 2x squared all over 4 minus x, and then all of that is raised to the power of 3. Now, if you look at that carefully, it's going to require more than one rule to find the derivative. In fact, immediately I can see the chain rule has to be applied. But the inside part is a quotient, which means that you're going to have to use the quotient rule as well. So let's just go right ahead. I hope I've got room here with my pen to be able to write all of these solutions down. Let me see if I can do this now. All right, so the first one. We have, 1 second, I'll get my pencil working. Okay. F prime of x is equal to. Now the first thing you're going to have to do here is use your chain rule. The 3 comes down in front. And then in a big set of brackets, we leave the inside part exactly as is. So that'll be x to the power of 3 plus, my goodness, this pen is not very good, 2x squared, squared, that's supposed to be a squared, all over 4 minus x, and then another big set of brackets on the outside, and that now becomes squared right there. So there, you can see we actually use the first part of the chain rule, but now we have a big multiply times, okay, big set of brackets, because now we have the quotient rule coming into play. So the quotient rule says we take the derivative of the top, so that would be 3x squared. Well, it's a good thing I've got the full solutions online. 3x squared plus, and then 4x. So there's the derivative of the top times the bottom. 4 minus x. And then subtract. No, I don't think I'm going to have enough room. Subtract. And then x to the power of 3. My goodness. X to the power of 3 plus 2x squared. Closing bracket. And now the derivative of the bottom is just what? Negative 1. So I write negative 1 there, and then another big set of closing bracket. And then that goes all over. And the bottom, which is 4 minus x, and all that squared. So you'll notice we had to use the quotient rule to find the derivative of the inside part. Now, that is your derivative, and you can leave it just like that. Hopefully yours looks a little neater than mine does. I wouldn't even venture to simplify that. You can if you like, especially this part over here, but it's not really necessary. You can just leave it as is. Okay. Let's look at the next one. Hopefully I can get this one a little neater. Here we go. Part B, you can see again, there's an inside part and there's an outside part. The inside part this time is actually 2 binomials, and the outside part has an exponent of 11 to it. So it's almost the same thing we have to do here. We're still going to have to start off by using the, we're going to start off by using the chain rule. So f prime of x is equal to, oh goodness, it's kind of tough. Okay, so here we go. The 11 comes down in front, and then a big set of brackets, and on the inside you have x minus, remember now the inside part doesn't change. X cubed, bracket, and then 14 plus x squared, closing bracket, and another closing bracket, and now we subtract 1 from that exponent, and that becomes an n. So you can see we've done the first part there. We've taken the derivative of the x side, but now we have to multiply that. And I don't think I've got room over here, so I'm going to go down below and just go to times. And now we have to take the derivative of the inside part. And that's going to involve the product rule. So here we go. We take the derivative of the first piece, which is 1 minus 21x squared. Now make sure you see what I'm doing there. Squared, because I can't see what I'm doing here. That's the derivative of the first part times the second, so that's 14 plus x squared, and then a plus sign. Notice all of this is in a big set of brackets. And then I go plus, and now there's just the first part, which is x minus 7x to the power of 3, bracket, and now the derivative of the second part, well, the 14 is just 0, and the derivative of x squared is just 2x, bracket, and then another containing bracket, closing bracket, because of the plus sign there. Now, believe it or not, that's your derivative. It's kind of long. It can be simplified if you wanted to simplify it, but it's probably not necessary. I think I'd probably leave it just like that right there. You can try to simplify it if you like. The next one, C. Now, if you look at that one carefully, what you've got is you've got a numerator and a denominator. They both contain x's. They're both functions of x. So you're definitely going to have to use your quotient rule. But the numerator is actually two functions itself. So that would involve the product rule. Now, here's a little bit of a warning about that one. If you thought what I wrote down before was messy, that one would be absolutely horrible. It's incredibly long. If you're looking at the completed solutions that I posted on D2L, you can have a look at it. I'll never give you something like that on a test or on a quiz. That's just too long, too difficult. You can try it if you like. Try it if you like. But to be honest with you, I just don't have the room here to write it down. So I'm going to leave that one. C, like I say, you can try it if you want, but it's up to yourself. The last one we have here is a little bit of a lesson. Now, this is the last one on page 42. There's some exercises further on that I'll get you to do after. If you look at this carefully, what does it look like we have? Well, we've got two parts multiplied together, two big pieces. So you're probably thinking product rule. Okay, but look at the first piece. It has a power of 2 on the outside, and the inside part is a quotient. So my goodness, what does that mean? Do we have a quotient rule and a product rule and two applications of the chain rule here? Is that what we have to do here? And the answer is nope, it's not. Because if you look carefully, a lot of these functions that start out looking difficult, they're actually pretty straightforward if you simplify first. So for something like this, and that's why they're giving you this example, they want to show you that simplifying sometimes can make a very, very difficult looking function, difficult to take the derivative. It can make it really simple. So just have a look, first of all, at this piece right there. Just have a look at that. And I want you to notice that if you could break that down, because you only have a monomial in the denominator, this piece would actually turn into, if you look at that, that's actually x squared. X to the 5 over x to the 3 is x squared. And this other piece right there, that is actually just 1, x cubed over x cubed. So here's what we're going to do. Whoops, I got it moved. Let me go back down. What we should do there is, first of all, change that y equals, and now all we have there is x squared minus 1 to the power of 2. My goodness, that looks easier already. In fact, That, folks, is just a binomial. Squaring that would not be difficult. X squared minus 1 times x squared minus 1 is actually a really simple binomial. And now if you look at the other part, people, like, that's just a monomial to the power of 3. You could actually take that 3 in with the 2, call that 2 to the power of 3, and then your x squared to the power of 3. Well, that's going to turn into x to the power of 6. So this actually turns into, let me go, times, oh goodness, times, that's not an x, that's a times, 8x to the power of 6. And it's looking easier already. It's looking a lot easier already. And in fact, what I'm going to suggest you do now is if you take that binomial right here, this part right here, and if you square that, you're actually going to get x to the power of 4. Now you can do this on your own if you like. X to the 4 minus x squared and another x squared, so that's minus 2x squared. And then you're also going to have 2 plus 1 times 8x to the 6. And now, why not just multiply through there by 8x to the 6? So here's what your function actually turns into. Y is equal to. Now believe me, it's much easier to simplify here than take the derivative of that monster. You're going to have 8x to the power of 10 minus 16x, and now that's an x squared there, remember, times x to the 6, so that's x to the 8. Okay. And what else are we going to have? Plus 8x to the 6. Now look how easy it's going to be to take the derivative of this and then just plug in x equals 1. So let me come down here below and kind of run that around there. So we got 1 times equal to, and this is such an easy derivative here now to take. 10 multiplied by 8 is 80x to the power of 9. Wow, this is really clumsy. 9. And then take away 16 times 8 is, well, let me see, what is it? 128. 128x to the power of 7 plus, and then 6 times 8 over here for the last term right there. That's 48x to the power of 5. And there's your derivative. Now, plugging in 1 is probably the easiest number you're ever going to be able to plug in, because all that happens is all of these x to the 9s and x to the 7s and x to the 5s, they all just turn into 1. So your derivative, y prime of 1, is really equal to 80 minus 128 plus 48. Let me see. I wonder what that's going to become. 120. Well, by golly, look at that. There's your derivative. There's your derivative. It's actually 0, which means that this curve, this really complicated looking curve up above, if you graphed it and found out where's x equals 1 to, well, folks, it's it would be a horizontal line. It's horizontal at that point. The tangent is horizontal there. And that's how we do mixed derivatives. Make sure you look at them carefully. I'm not going to give you any that are like very, very complicated, like C was. Forget that. I might give you one like some of the others, though. But just look them over. And there, like I say, there's some practice problems later on, and I'll tell you which pages to work on after I do the third video here right now. So I'll stop here now, and I'll make up the second derivative, which is on, or not second derivative. I'll make up the second video on something called implicit differentiation. Okay, so just hang on.